circumflex, you go in through angiography and you dissolve the clot or aspirate the clot, you restore blood flow, and this patient actually recovered very nicely. But if you don't restore the blood flow, the heart dies, the patient dies. So the point here is you have to have sufficient blood flow to treat acute disease such as an MI, or to treat chronic disease such as slow progressive vascular dementia or any other end organ disease. So this is going to go for 50 minutes, but if you wanted to stop off right now, if you had something else to do, this is the most important slide. Nitric oxide deficiency causes chronic disease, increases your risk and sickness and mortality from viral infections, including coronavirus. And I'll touch on that later. So the most important thing you can do is enhance your body's ability to make nitric oxide. That's the take-home message. Now, the detail of that is how do you do it? How best to do this? Everybody's different, and so we have to look at personalized medicine and get to the root cause of what's causing nitric oxide deficiency. So again, this is kind of a rehash here, but every single chronic disease is characterized by decreased blood flow. But in the scientific literature, it's known that if you can restore blood flow and perfusion to every organ, tissue, and cell in the body, you can correct most, if not all, chronic diseases, because the human body heals itself. That's just the way we're made. So the fundamental question is, how do you restore blood flow and perfusion to specific organs and tissues and cells throughout the body? And that's where this molecule, nitric oxide, is absolutely essential. You cannot do it without nitric oxide. And this was so important that a Nobel Prize was awarded in 1998, and Val Fuster was famously quoted as saying that the discovery of nitric oxide and its function is one of the most important in the history of cardiovascular medicine. And at the time of its discovery, we thought, or we knew, that it was important as a vasodilator, meaning that it dilated blood vessels, increased blood flow and oxygen delivery to downstream tissue. In the 30 plus years since that discovery, we've learned that it's a signaling molecule. So the basis for its importance is how it signals. And this paper here, published by Jonathan Stammer in 2015, really illustrated the importance of nitric oxide as a signaling molecule, independent of its vasodilatory properties. So most of you are familiar with the cardiorespiratory cycle, where we breathe in oxygen, it binds to hemoglobin, it's transported throughout the body. And when it goes to this arterial venous transit, hemoglobin undergoes an allosteric transition, a change in structure. It releases oxygen, picks up CO2, and the venous circulation excretes it through the lungs. But this paper here demonstrated that you need nitric oxide bound to a single cysteine residue on the beta chain of hemoglobin in order for oxygen to come off. If you don't have nitric oxide bound to hemoglobin, oxygen will not come off. And over the past 2 years, this has become very apparent in COVID patients, because the problem in coronavirus infection is the loss of oxygen saturation. You give them 100% oxygen, increase the flow rate, but many times you don't increase the oxygen saturation. Why is that? Because they're missing nitric oxide. If you restore nitric oxide, you improve oxygenation, and more importantly, you improve delivery of that oxygen to every cell, tissue, and organ in the body. So your body cannot and will not heal or improve oxygenation without nitric oxide. And I'll show you how we're developing nitric oxide-based therapeutics for COVID that's showing that nitric oxide is what's necessary and sufficient for improving coronavirus infection, sickness, and death. And it's more than just the vasodilating the cardiovascular system. It's how our own immune system kills off invading pathogens like viruses and bacteria. So when we become infected, whether a bacteria or a virus, our immune system mobilizes,